Hi, welcome back to the Network Plus Certification video series. I'm Mike Redmond, Master Trainer, here to help guide you through your successful journey of becoming a Network Plus certified technician. We're going to walk through a wide variety of topics, starting with basic network concepts all the way through network management and security. In this segment, we're going to take a look at virtualization. I'll describe the concepts of virtualization, explain why PC and network administrators have widely adopted virtualization, and describe how virtualization has manifested itself in modern networks. Virtualization is called the next big thing in the computer industry. Virtualization creates a complete environment for guest operating systems to function as if they were installed on their own computer. Guest environments are called a virtual machines. The individual machines or entire networks can be virtualized. So what is virtualization? Most people have heard of virtual reality. It's a virtual world created by software with sight and sound and even today smell and feel. Primarily used for gaming, flight simulation, military, and first responders. The equipment, such as goggles and special gloves, enable you to see and move objects within this virtual world. Computer virtualization is similar. The operating system is what's virtual. So with computer virtualization, it virtualizes computers and networks. Virtualization convinces the guest operating system that it's operating on its own with its own hardware. It runs on a host operating system that is the physical machine that it's operating on, but the guest operating systems are actually the virtual ones, but they have no idea. They use things called hypervisors and virtual machine managers to create and manage virtual machines and their interactions with their host environments. So with a hypervisor, it is a single OS uses a program called a supervisor. It handles the very low-level interaction among the hardware and software. Full virtualization requires an extra layer of programming to manage those complex interactions of hosts and guest machines. That's where the hypervisor and the virtual machine manager, the VMM, comes in. The hypervisor handles the input and output requests. It allocates real hardware to virtual machines like disk drives and RAM. It enables easy addition and removal of virtual hard drives and virtual network cards. Virtualization even goes so far as to virtualize the BIOS and the system setup. Being familiar with the BIOS, that is long before it even gets to an operating system, but it convinces the operating system that an actual BIOS is there. This is a look at the BIOS from a Microsoft Virtual PC. So there's confusion between what is virtualization and what is emulation. So virtualization uses hardware from the host system and divides it into individual virtual machines. It abstracts hardware that is of the same platform. It can't virtualize the hardware itself for a different platform. That's like trying to make an Intel processor be a Sony PlayStation. However, that's where emulation comes in. Emulation is very different. It does not virtualize the hardware. It enables software written for a different platform to run. That's how you can play Nintendo's Mario Brothers on a Windows PC. So I'm going to take you through a short walk of virtualization. It's setting up, for instance, a Linux machine. I'm going to use a Windows 7 machine as the host OS and a program called VMware Workstation is going to be my manager. So starting with the VMware Workstation, it's not free, but you can download a 30-day trial of it. This is what's going to actually manage our virtual machine. So to get started, just simply click on New Virtual Machine, and it's going to prompt you for a choice, either a typical or a custom setup. But this time, we're just going to do a basic custom setup of a virtual machine. At that time, the VMware Workstation enables you to use either the host's optical drive or CD drive, or to load off of an ISO. At that point, it's going to automatically configure all the virtual hardware settings: RAM, virtual hard disk drive, sound, NICs. Now, you can change this at this time, or you can change it anytime later. That is one of the beautiful parts of virtualization. VMware even ensures that the boot order in your new virtual system is set up and configured to boot first from the installation media, whether that was a CD or a DVD or an ISO. It gives you the standard boot screen as if you were actually booting into that physical device. After the standard installation of whichever operating system you've chosen as your guest OS, we just happen to choose Ubuntu Linux, now you have your installed machine sitting there in VMware Workstation, ready to do whatever I need it to do, whether it be research or maybe I just want to do or play some games that are only available on Linux and I can't run somewhere else. It's there for me to have. It's stored as a basic system file. So when you first start it up, you'll run through a post process like you would any other computer. That is virtualization in a nutshell. Now, yes, it will take a little longer to install these pieces, but that really is as easy as it is. So why do we virtualize? What is the overall benefit of virtualization? Well, two important reasons. To reduce the number of physical machines. Plus, and this is a big plus, the ease of administration that virtualization brings, especially when it comes to backups, security, portability. There are some other important reasons like power saving and system recovery that go into it, but those are the two primaries. So, power saving. Before virtualization, each server OS needed to be on a unique physical system. Now, after virtualization, you can place multiple virtual servers on a single physical system, reducing your overall power consumption, and that's a good thing. It allows us to consolidate our hardware requirements, a smaller IT footprint, you'll hear it called. Virtualization makes it possible to increase the RAM of our individual servers and run on a single server. When it comes to system recovery, which is, again, one of the most popular reasons for virtualization, virtualization allows us to maintain an extremely high uptime. It makes it possible for a system to shut down, reload into an alternative copy in minutes, where it used to take us hours. We do this by taking snapshots along the way. It's little pictures, if you will, of the last known good state of that machine. So, for instance, if you install a patch that causes the workstation or server to be unstable, all you have to do is go back to your snapshot. Again, in minutes, not hours, you're back up and operational. If you've ever been part of a large rollout of systems, maybe it's a new network or a new organization, VMs and loading a virtual environment makes this extremely easy. You can mass duplicate complete systems in a matter of hours, lay out an entire virtual network in less than a day. That, before virtualization, would take an army of people, and you'd still spend weeks or months configuring each individual system. So, what does virtualization look like in our modern networks? The products so far that you've seen are meant for small scale, small implementation, single computers or laptops, not really suitable for large scale implementation. For that, we need to take a different approach. That is where we come into bare metal supervisors. There's no operating system necessary. The virtualization software is the operating system. Most popular is a product called ESX. Now they've moved to ESXi, which the I just simply stands for embedded. With ESX, you have an extremely small storage footprint. As a matter of fact, the entire ESX operating system fits on a single thumb drive. So there are some differences between virtual machine managers and bare metal hypervisors. With virtual machine managers, it's software that runs on top of a host operating system. With a bare metal hypervisor, the hypervisor is that software. It doesn't need any underlying host. So there are many choices when it comes to the virtual machine managers. You have what I've just shown you with VMware Workstation. Microsoft has Microsoft Virtual PC. There's a program called Parallels, popular on Macs, and KVM for Linux. VMware Workstation is the industry leader. They have led the charge really for full virtualization, starting with OSs and now all the way to full infrastructures, network routers and switches. It comes in two different versions, Linux or Windows, whichever suits your organization best, and it offers an extremely robust suite of tools to do anything that you will need to do in that organization. It makes the interactions between the guests and the hosts near seamless. Now, Microsoft's Virtual PC is a free product, unlike the VMware products. However, it does have some limitations. Now, officially, it supports Windows VMs, but Linux VMs can be installed and managed through the Microsoft Virtual PC. And again, Parallels. This allows you to fully virtualize a Windows operating system on top of your Mac Air or Mac Pro, it doesn't matter. Make your desktop look like a Windows PC, like it has done to mine here. KVM is, again, an open source product, which means it's free. It's a product supported by Red Hat. Most Linux, Unix users use KVM. It supports very few non-x86 processors, though. So again, you have some limitations, but a very good system, especially if you just want to get to know and learn some of these virtual machine managers. Now, there are some other products out there. For instance, I've used Sun VirtualBox, often prefer it to some of the other products. Again, especially if you're trying to learn your way around virtual environments. So that brings us to the hypervisors, the bare metal hypervisors. We've already spoken briefly about VMware's ESX, and Microsoft has their own version of the hypervisor called the Hyper-V. Now, ESX is the market leader. Several features offered, even full support for large storage like NASs and SANs, completely transparent and automatically fault tolerant. It fails over to itself, and full support for up to 32 CPUs. That is a lot of processing power. Now, Microsoft's Hyper-V, not to be outdone, is available for 64-bit systems. Previously, you could only get it as part of the Windows Server platforms. However, now it comes as its own free standalone product. So now that you understand the difference between the virtual machine managers and the hypervisors, let's add some additional to it. The virtual switches. This addresses the problems that we've run into with multiple virtual machines. Again, as long as you have enough hard drive space, you can virtualize operating systems and machines over and over and over again. However, we've always been limited by the number of NICs on the host. Most of them only have one or two. The virtual switches allow the virtual machines to communicate with each other within the environment, as well as the host and the network, even the internet. All virtual switches, like a physical switch, get their own IP address information. Now, it does this by two primary methods, either bridging or virtual switching. Bridging gives each virtual NIC a connection to the real NIC, whereas virtual switching enables the VMs to communicate only with each other and no outside connection. So depending on the type of environment that you're setting up, perhaps it's a full research environment that you want to ensure to fully isolate from your production environment. You can set up an entire virtual world where they will only ever be able to connect and talk to each other without any risk of them getting out of that virtual space and into your production environment. We've gone so far as to virtualize our telephone system with virtual PBXs. PBX is a private branch exchange. We do this simply with software running on a computer. You might be familiar with a product called Call Manager from Cisco. You can even run your entire telephone system in the cloud. A product called Free PBX, free to use. Now, small organizations can set up an entire telephone communication system just like a large organization without the overhead and expense. This is progress at its best. Next, let's talk about storage, starting with SANs, or storage area networks. Two primary modes or two primary ways to connect a SAN, either with fiber channel or fiber channel over Ethernet, which is the most popular today, or iSCSI, or Internet Small Computer System Interface. Fiber channel or fiber channel over Ethernet, extremely high performance, typically not cost effective for long distance runs though. With iSCSI, it uses the iSCSI protocol over TCP/IP, extremely cheap and readily available. However, again, not optimal for high performance environments. Next, you have a NAS, network attached storage, a dedicated file system with its usually own proprietary operating system, extremely cost effective, a lot more cost effective than individual servers serving out files over the network. However, again, not the optimal solution for a high performance environment. And that brings us to the cloud. The cloud is really a vast array of on-demand computing resources. Google, Amazon, Microsoft all have cloud offering. They have service layers of cloud. For instance, at the base layer, infrastructure as a service, at the middle layer, platform as a service, and at the top layer, software as a service. With infrastructure as a service, it minimizes idle hardware, protects against data loss and downtime, and responds to spikes in demand. You can create resources on the fly with virtual servers and workstations. However, to administer a infrastructure as a service, it does require skilled administrators. With platform as a service, you can deploy, administer, and maintain an entire web application almost in a turnkey platform. easy to allocate resources based on need and customer requirement. This is outstanding for smaller or medium-sized organizations that see a spike in sales around Christmas time, but they don't need all those additional resources in the summer. It allows them to only kind of pay for what they use. And software as a service. This is ideal for customers that say, just make it work. Extremely easy on the pocketbook. However, there is a somewhat increased risk due to the lack of control over sensitive or intellectual property, because this is providing access to necessary applications wherever you have an internet connection, often without having to carry data with you, thumb drives and external hard drives. So there are multiple offerings of the cloud, public clouds, private clouds, even hybrid clouds. The difference between them is the public cloud is there for general public use. Anyone can use it. Google and Amazon have free offerings of the cloud. Private clouds, only you and your organization have access and ownership of the private cloud. This helps when an organization needs complete ownership of its data and its data resources, or hybrids of the two. This allows for non-critical services to be hosted in a public forum, which in turn allows for data to be utilized in a more cost-effective platform, but yet still keep some amount of control over data flow and proprietary information. Well, there you have it. Pretty simple, right? I know, it can be a lot of information coming at you all at once, but don't worry. I'm here to guide you every step of the way. You can do this. Just remember, study hard, lots of practice questions, and you will succeed. You will become a Network Plus certified technician. I'll see you next time.